All right. Are you ready? We're going to start chapter 4. Chapter 4 is a hodgepodge of topics. Well, it's mostly about exponential and logarithmic functions. The entire chapter. Logarithmic, it's just got a nice name to it. It needs a fucking Y in it because it says rhythmic, and then rhythm has a Y, but it doesn't. Exponential and logarithmic functions. These functions are inverses of each other. So 4.1 starts with that. 4.1 starts on inverse functions. We've already talked about how an equation needs to pass a vertical line test to be a function. Needy little bitch.
Oh, yeah. I don't want to watch.
Oh my god. Yes.
We got like what, maybe a month? Like 5 weeks, man.
You got by it like the last week of school. Not even.
All right, listen, I bought one like mid semester and I lost it. Okay, so that's fine.
Did you?
Yes, I
You
did.
didn't have it very long because you've been asking him for that fucking sharpener since fucking damn near day one. It might have been day one, although I don't think there was any writing down on day one, so maybe it wasn't day one. We've already talked about how an equation needs to pass the vertical line test to be a function. We'll call that f of x. And we'll do the vertical line test as red. Vertical line test says no vertical line crosses the function more than once. Just as a reminder. This is f of x more than once. Fuck now.
Suck it out of body. That's it.
Do you all? Oh, damn, I was almost. Remember we were talking about when no one was in here and I said I was gonna make a problem about it?
All right.
I almost just went with it right now.
Oh, yeah, don't do that. Please don't do that.
It'd be so funny though.
No.
Are you sure? Okay.
Yeah.
I'm not allowed to bully students, apparently. They got some sort of rule about it. I don't know why. They really don't know what they're missing. Why do I have a fucking pin up here without a cap? Well, that's not good. Is it in my pocket? Did it not make it out of my pocket? Nope. I don't know what. I guess we'll just use that one until it doesn't work no more. There's also something called the horizontal line test. Guess what you do for that? You draw horizontal lines and make sure the line doesn't cross the function. No horizontal line crosses the function more than once. It can look like it's crossing it more or get close to it, like if it's almost parallel. If a function passes both tests, Yeah, it's already dead, it just came out dead. If a function passes both tests. We say it's a one-to-one function. That's fucking great. Every once in a while, something makes me think of it and I just giggle about it. He's alive. Not handicapped, everything fucking fixes itself. Different if he's permanently disabled or something, that wouldn't be fucking funny either.
You told me you turned me red.
Yeah, it's fucking funny. Well,
Okay.
I was giggling at it, and then he's telling me what a horrible person I am. That's what made me fucking like take my breath away.
Wait, did your mom stop on top of it?
So somewhat a little bit, yeah.
Dude. That's crazy.
When the bump felt like more than it should have been, she's like, what was underneath the fucking car? I said, go roll back forward, go back forward. Cause if she was like barely up on it. And she kept going, she would have done more damage.
He was screaming, or was he just?
I don't remember if the fucking radio was turned on when the car started or what. He didn't wake up when the engine started or so, he fell fucking asleep on me there.
Oh, he wasn't sleeping. Oh,
Otherwise, he would have fucking not stayed positioned, I would like to think he's not. That dumb, yeah, I would like to think he's not that stupid. Alright, so a function that passes a horizontal line test is called a one-to-one function. What this means, in other words, without doing the line, it means like the vertical line test said. For every X, there's only one Y. And if it passes this bad boy. For every Y, there's only one X. Not a lot of functions are like this. This requires f of x to be either A, always increasing, like pictured above. That graph's always increasing as it goes to the right, or B, always decreasing. This eliminates most functions. Most functions are not one-to-one. Functions with only odd exponent, like just a single single term with an odd exponent, tend to do it. Regardless of the coefficient in front. N equals 1, 3, 5, 7, even the negative ones. F of x is x to the -1 is really 1 over x. And we looked at the graph of 1 over x last week. Well, Monday. So all of those work. Now, to show that it's not, a one-to-one function. To show a function isn't one-to-one. Let's try this again. Don't get me started, Jimmy. I already know your fucking weak spot today.
That's not that bad.
So I can do it.
Sure.
You fucking call my bluff. No, they're like, you do say and I can do it. It kind of makes me not want to do it. It's like not as fun anymore. What a dick. How would you do that? Show function is a one-to-one, find two x values that produce the same y. Now you want me to it? Well, no, now I'm not going to.
What's the point of the two ends? N equals 1, 3, 5, 7. And the bottom is the same thing.
Negative, no, it's got a negative sign.
That's not even.
They could be negative odds.
Oh, okay. So there's just only negative 1.
No, I my bad. I see what you're saying.
Oh,
All the odd numbers. And what the fuck are you talking about? I see what you're saying. I didn't make it clear. So like y equals x squared. If you graph it, it's really clear that it's not one-to-one. God, that's a fucking. How about we just like do a real straight line? So you can see right away that fails the horizontal line test. It crosses here and here. Waves.
So if it hits the horizontal line 2 times, it fails.
Yes, that fails the horizontal line test. It's still a function.
Okay.
It's a function, but it's not a one-to-one function.
So a y equal x would hit it only once, right?
Y equals x would hit only once, yes.
Okay.
Another way of showing it fails it is by plugging in two different x values and getting the same y value. Both produce 4. What are you going on about now? What the fuck is wrong with you?
One looks like a me, I thought it said a me too when I'm like, what the hell does that mean? Looks like an M. Thank you.
Alright, you guys ready for more? Alright, assuming we have one function. If f of x is a one-to-one function. It has an inverse function. Which we usually denote as f negative 1x. The negative 1 is not an exponent. It denotes the inverse. Why? I don't fucking know. They could have so easily made it an I right there. And then it would have been no fucking confusion.
What's that?
Yeah, I was gonna say, what's that symbol?
Is there a symbol or?
What?
That,
That.
another negative one.
It's an arrow.
Oh.
See, I'm not the only one confused.
We can look bad.
Yeah, you're gonna put yourself in the same boat as Luis?
Oh.
You can't even drive straight.
Me, it wasn't me.
Yeah,
It was someone.
He's not the one that.
Someone named Park Rex.
So you say,
So I
wait, someone didn't park right? Is,
I guess they're trying to go in, try to go in like on ice, I guess, and then they just start like
so they hit you.
basically.
You ever been to-
So you say,
Were you in the car when it happened?
They let them know. And I'm like, oh shit. I didn't even see the scratch. And so I saw a note.
Oh, she let the know.
Yeah.
well, that's nice.
I was like, what is it? And I saw the side of the door. I was like, oh, it was pure styrofoam. It was all white. I was like, it started like scraping. I was like, that wasn't that bad. I like a hurt
Buff
car.
it out.
Yeah, and I had like a hurt car. The front bumper's like, it's messed up. Like that on the switch really.
She didn't even move, she still parked there.
Yeah, it's hilarious. You park right next to me. I was like, okay.
Fuck it, I'm not gonna fucking run into another car. I'll stay right here. It's fucking great. We usually do, we call G of X. We use something else other than inverse while we're doing it. At least until we can show it. Once we show G of X is F inverse of X, we leave it as G of X. Which makes you might wonder, how do we show when a function is an inverse of another function? If f of g of x equals x, and g of f of x equals x, then f and g are inverses. It's my first time teaching Calculus 1. And I borrowed some resource material from other teachers. And I gave them a review for they have an exam on tomorrow. I gave him the review last week on Thursday. I said, I'll put up a solution key. And when I looked at the exam, it didn't really look all that hard. I spent like fucking 10 hours on that motherfucker. They were fucking freaking out like over the weekend. I'm like, I'm working on it. It's 13 pages. Like, one of the problems literally took 2 fucking pages. It was a fucking polynomial. It was a simple polynomial, and it was like graph it, which meant finding all the roots, and none of it fucking failed. That P over Q shit we didn't work for any of them. None of the roots were rational. And so they found out have a method in that class to find roots that are not rational. It's called the Newton's method. It's not that bad. It just requires doing something in the calculator, getting it set up in the calculator, and then you go through it really quickly. But like most students just go, nope. I don't even know where to go with finding the roots. And without knowing where it crosses the x-axis, it's kind of hard to graph a line. We require a little more accuracy out of the graphing than we do of you guys. Let's take a look at an example here. F of x equals 2x plus 5. G of x equals 1/2 x minus 5. Is G the inverse of F? Like the problem that looked like the easiest problem on the test was the one that fucking took 2 pages. The one that looked like really the hardest didn't take me that long once I actually got started and drew a good picture. Well, let's check this. We check this by seeing if this is satisfied. So we will do fog x. So everywhere we see x in f of x, we're going to stick in g of x. If I distribute this, I get x minus 10 plus 5, which equals x minus 5. So f and g, this does not equal x. So f and g are not inverses. Which is funny because if you do a slight bit of tweaking on g of x, it is. What if g of x is 1/2 times x minus 5 like that? Or if you don't like it that way, 1/2 x minus 5/2. So we look at log x. Distribute the 2 hits the 1/2 and cancels, and we're left with x minus 5 plus 5. It's x. And we can check Goff x, where we're taking 2x plus 5 and sticking it into g. So I have 1/2. And then I'm gonna put in 2x plus 5. And then I had -5 here. So we clean this up a little bit. That's 1/2, the 5 and -5 cancel out. We have 2x. And 1/2 times 2 is just 1, so we get x. So f of x equals 2x plus 5. And g of x equals 1/2 parentheses x minus 5 are inverses. So that whole like f of g that y'all hated, most people don't like it, it's back. Interesting thing about inverse functions, let's graph these. I'm gonna try to do it well. I should probably do it in Desmos, but I want you guys to see it here. Maybe do this. 1, 2, 3, 4, 5, 10. 1, 2, 3, 4, 5. I feel like the top half has a much bigger. Ah, fuck. Oh well. It is what it is. 2x plus 5 has a slope of 2/1. And g of x is 1/2 x minus 5/2, which means it starts down here at negative 2.5. And every time it goes up 1, it goes right 2. Now, it may not stand out until I actually show it, but the line y equals x is this. If this is graphed well, you can see they are reflections of each other over the y equals x line.
I just have a question. What is the slope of y equal x? Oh, never mind. Never mind. Dumb question.
Ever notice this way says I just have a question? Not like I have a question. I just have a question. Like he's not gonna do anything, he's not gonna tell a story, or there's no joke, there's no laughing or humor, he just has a question.
That's what makes it humorous.
He did really well on the test, so whatever he's doing is working. Another interesting property for this y equals x thing. If f of x has xy, and we've got like x1, y1, x2, y2, x3, y3. This is f of x. And these are numbers, and that should be a 1. F inverse of x, for its x and y chart, we'll have y1, x1, y2, x2, y3, x3. I know. The domain and range are swapped. Inverses. So if you have a bunch of points, like let's say the inverse is going to have this. And you don't even know what you need to know what the function is. You just swap the x and y values. Swap x and y values as you go from one to the other. Sorry, this should say xy up here. I wrote yx for some fucking reason. Nope, doesn't switch the signs or anything, it just switches the values. In fact, the function I've given here on the left, which we're going to look at in 4.2, this is y equals 2 to the x. It's called an exponential function. It's in 4.2. I don't know which section this is in, but this is its inverse. Which is the logarithmic function. Y equals log base 2 of x. 4.3 or 4, I don't know, something later. We're doing exponentials and logarithms in this chapter. And since they're inverses of each other and they're derived from each other, you have to go over inverses first. You don't look like you like this, Jim. Swapping x and y a little bit too rough for you? It is boring. How dare you, sir? Really say it's fucking hard and boring. It's insulting. Shall we have fun at Jimmy's expense? No, I'll get in trouble. Someone's a fucking snitch in this room. I know it. I can feel it. I don't know who it is. There's gonna be a snitch. There's always a snitch. Snitches go in ditches. Stitches is too you're going too light on. They need to not walk away from that motherfucker.
Crazy.
All right, so how can you find an inverse? Or a one-to-one function? That's better. Fake it. Why don't we use the f of x equals 2x plus 5 earlier? Step 1. Replace f of x with y. It's a shitty pen. It's not easy to work with if you have f of x in there. It's just a pain in the ass. I mean, you can do it with f of x in there, but you'll see why I say switch it out. Step 2. Swap x and y. Step 3. Solve for y. So here I did 1, here I did 2, and we're on 3 right now. We're gonna subtract 5 from both sides. I get x minus 5 equals 2y. And then we'll divide by 2. And I get y equals x minus 5 over 2, or I can write that as 1/2 times x minus 5. Step 4, which is an easily forgotten step, replace y with f inverse. Bam. You know, your test is damn near in 1 month, final. December 11th, you're almost done.
Go by quick.
Yeah,
It did kind of go by quick, didn't it? You're gonna be sad when you don't have me no more.
We're like how many chapters? Because actually we did like chapter.
Why do we need to count the chapters? Does it matter?
No, I'm just saying because we already are in chapter like 4.
Yeah.
Yeah, so it's going fast.
No, yeah, we've been going slow, actually. I plan on being well ahead here right by now. I don't know. It always seems too slow, so I gotta slow down for him.
Talk to me during the first week.
yeah.
That has not stopped other semesters. I always use the first week to
First week was
do some,
no math.
That first week felt.
wow. Seems like you could have paid attention more and gotten some better study habits out of it. Learn some fucking shit from it. All right. So your turn, you try. G of x equals 4x minus 7. And then when you want to really engage yourself, then try h of x equals x cubed plus 5. Find the inverses. You can also take a bathroom break right now if you'd like. We'll go over these problems together in like 10 minutes or so, maybe 15 minutes. It gives you time for a little short break and other things. A long time ago, when before we had Math 35 here, we had Math 230 and Math. I don't remember the other fucking one. It was Algebra 1, Algebra 2. And I had a student, she'd been my student for a couple semesters, she'd been attending there in sequence. And she started working at C's like during winter for Christmas. And she came in and it was like near the end, she wanted to give me a box of C's candy for being her teacher for a while. And I'm like, oh, thanks. I went over and I gave her a hug. And from working at C's Candy, I couldn't help but notice she smelled like chocolate. And the room was deathly silent. It was like class hadn't started. And I involuntarily went,
Oh.
you smell good. And everybody in the class looked up like, and I looked around the room and she fucking laughed because she knew she smelled like chocolate. She'd heard it from multiple people. I'm like, no. She smells like fucking chocolate, people. I'm not fucking being creepy. She smells like, but from fucking everybody else's perspective,
Yeah.
I'm like, holy shit.
You're rushing people.
No, let's give her a hug, thanking her.
That's crazy.
Yeah. Fuck. I didn't realize. Like the way it was coming across everybody, and I fucking looked, because my eyes closed as because it just smelled so good.
I just have a question. When you swap the y by the x, you only change the y and the x. You don't change like what power it is rise or
Just
whatever.
change the letters, then you leave the powers where they were. So
Okay,
like on the right one, you'll have x equals y cubed plus 5.
At least smaller.
Okay.
Well, you hit it on, you hit a push pull leg?
I do Monday legs and Thursday legs. But
Oh.
I start my week off with them.
Oh, could you just get it over with?
Yeah, it's not like hitting legs.
Yeah, no, that's it.
Instead of push pull legs, I do legs, push pull.
Legs,
So I
pull.
just swap it, yeah.
I could pull, push, like, yeah. I just
Back
have
stuff's
to,
fun too.
back,
Yeah, back is. Oh,
oh, yeah, yeah, yeah. I just don't like legs.
I love doing legs, it's actually my favorite.
Is it?
Yeah. I hate hitting chest around.
I like it just because that's my weak point, so like, kind of,
Chest is my weak point.
yeah.
Legs are great. I love legs.
Terrible.
What? I wish every day was leg day. Why you gotta call me terrible? That's not very nice.
No, it's not. You're right. I'm not sorry, but.
I know you're not. You really want me to do the fucking thing, don't you?
Nah.
You sure as hell fucking asking for it.
Oh. It's a snack.
Wow.
What?
Steal the kids' snacks?
I ain't even know what I said.
It doesn't matter. That's all I heard. That's enough. I'll take it out of context if I don't.
The context behind it.
I'm okay with that. I'm okay with putting words in your mouth too.
That's not a good thing. So do that.
You didn't care a second ago. Why do you care now?
You know, words in my mouth?
Yeah.
Oh, I do care about that. You're framing.
Depends on what I say.
You should. Saturday? Oh, that's right, yeah.
You know, I stayed up till fucking 2 in the morning, 2:30 in the morning. I didn't see my fucking phone turn.
It does.
I was reading on my Kindle.
I don't think
Either I fucking didn't check, I was deliberately wanting to see the time change.
it doesn't change that too.
It changes at 2 AM. It's supposed to go back to 1 AM.
No, goes from 12 to, no, from 1 to 12, I think.
You have no idea what you're talking about.
Yeah, I've stayed up
It's
to
at
watch.
2 AM.
I've stayed up to watch.
The time changes officially at 2 AM. When it's falling backwards in fall, it's supposed to go back to 1 AM. It doesn't matter. I was watching it from like 11 PM onward.
You're right, never mind.
I was reading on my Kindle. Apparently, I wasn't checking it often enough. Cause I never saw like the time go backwards. So there was a point in there that I had read for at least an hour and didn't look. And I was fucking staying up to look for it. The next thing I know, it's fucking 2:30. I'm like, son of a bitch, I gotta go to work in the morning. Well, not in the morning. I gotta work in the afternoon. I fucking trying to force myself to sleep at that point. It was not pretty.
It does change. I've seen it change.
Yeah, I'm saying.
I know it changes. I'm just saying I didn't see it fucking change.
Such for you.
Look at this kid fucking mouthy all of a sudden. It did suck for me. I stayed up late for it. Thanks for noticing it sucked for me. That's okay. I live.
You gaming on.
I am. I have a few minutes. Jerry, Luis is not back. Take the break where you can get it. It's better than hanging out with you.
It's also true.
Look, shots fired.
Watch out for the car.
Oh. Dirty. Don't do me dirty like that, man. That's not right. Why you gotta do that?
That's 3 tires, I'll spray you one.
Just 3 tires?
I'll spray you
That's fucked up. Can't believe you would imply that you would slash my tires or some shit like that.
one. I never said that.
That's why I said imply. You didn't actually use the words that you were gonna do it, but you just kind of like implied that you were going to.
I'm saying we can't send you 3 tires.
Blessed be the wind. The divine wind. I do think I'm gonna try to pick up calculus 1 for next fall out here. So if you take pre-calc B in spring and you enjoy my class, you're welcome to take Math 65, which is calculus 1 with me in spring or fall.
Do you do summer courses?
I do. We're picking summer courses on the 7th. December 7th.
Teachers aren't required to do summer courses. I'm just
Nope.
saying,
You get making $90 an hour.
if they do.
Hmm.
That's super good.
This last summer was fucking phenomenal. Because I had some online courses with my full day of face-to-face courses. My take-home check just from summer courses was like 18K. That was after taxes.
For the whole summer?
Yeah, for no, it was, well, yeah, it was all summer, but it was only 1 month.
Yeah,
I worked July, I didn't work in June. Took June off.
1 month.
Well, I literally I had classes from 7:30 until like 5, 4 days a week. And then online stuff that I had to answer emails and stuff at night,
I was like,
but. I ain't never made anything anywhere near like that kind of money in a month. I almost canceled direct deposit. So I could hold that motherfucker in my hand, you know?
Yeah.
Cause that fucking pay stub they give you with like direct deposit, it's not the same. It looks like the check, but it's not the check. You walk in, you walk right back out. What the fuck? That boy ain't right. Oh, he's back. Turn that off. I don't know that I paused the lecture. No, it just fucking kept recording the whole goddamn time. Fuck it. All right, looks like everybody's back. It's been long enough. So we're gonna make this y equals 4x minus 7. Then we swap the x and the y. So here we did the swap. Now I'll solve for y. And I'll multiply both sides by 1/4. And finally, I will return back to the original function, but make it the inverse. G inverse x equals 1/4 x plus 7. If you had 1/4 x plus 7/4, that works. If you had x plus 7/4, that works as well. Any questions on the left side? Here we'll do the swap. Now I will solve for y. And we gotta take the cube root to get rid of the cube root on the y. And we get the cube root of x minus 5 equals y. And now we'll go back to the inverse.
I just have a question. There's not the plus and minus sign here.
No,
Why?
because it's an odd root.
Oh, okay, okay.
This is correct. If you have cube root of x minus cube root of 5, that's wrong. The cube root hit the entire side all at once.
Okay, so if I have I mean, if there's only one result, there cannot be like two of like the one you show.
Correct. This
Oh.
is wrong. This does not equal that.
So if it was in a square root instead of a cubic root, that would be wrong.
That would be wrong.
No.
Because if you take the square root of x cubed, you don't end up, if you take the square root of y cubed, you don't end up with y.
You.
You end up with y to the 3/2. That's easy mode. Now. Let you write it down. A lot of things aren't intuitive here. So we'll put the y in. And then we'll swap them. Everywhere that has a y becomes an x, and everywhere that has an x becomes a y. Do our swap. So we can clear fractions by multiplying both sides by y minus 5. I'm going to distribute on the left. I have xy minus 5x. On the right side, I just have negative 3y plus 1. I want to pause and make sure everyone's good with that. We want to solve for y, so gather the y's on one side. And everything else on the other. So I'm going to add 3y to both sides. And since I'm gathering my y's on the left, I'm going to move the 5x by adding 5x to both sides. I now have xy plus 3y equals 5x plus 1. While a little complicated, most people are okay up to there. The next step just really bakes people's noodles. I'm not sure why, but what we want to do is these both have y in them as a factor. We are going to factor out the y. Finally, we want y by itself. It's got shit multiplied by it. So we divide that shit out. And we get y equals 5x plus 1 over x plus 3. And now we can write it as the inverse. One more idea in this section. Is there any questions on that one? It's not the most fun one. It's one of the longest ones, is why people tend to apparently the longer a problem is, the more likely a student is to not like it. Oddly, I'm the other way. Like I'm like, I have to do a long one. But when I'm done with the long one, I was like, fuck yeah, I did that shit. That was me. I did that. Like that problem I was telling you in the review, there was 2 fucking pages. I actually fucking did it. And I was like, yeah, that's right. And I checked it in Desmos to make sure it was a graphing problem. Checked it on Desmos to make sure I fucking did everything right. It's like, yeah, graph looks the same. All right, last concept in 4.1 is when we have a restricted domain. What happens with restricted domains? F of x equals x squared plus 4. As it is, it is not 1-to-1. If we restrict the domain to be x is greater than or equal to 0, f of x is 1-to-1. So it's 1-to-1 now, we go and find the inverse. We put in our y, we swap it. Jimmy's going to the bathroom now. After that fucking like 15-minute bathroom break. Jimmy. Finally, we take the square root and we get y, which equals f inverse of x, is the square root of x minus 4. I can show this to you guys on Desmos. So to infect. What happens to this? It looks like that info kind of went away. Because, and Josue hasn't asked it yet, I took the square root of both sides.
Yes, that's what I was about to ask you.
So I should have plus or minus, but I did not. Should have plus or minus when we take the square root. And yet, I'm going to double down and say f inverse of x is just the positive one. Why did I eliminate the negative? Most people don't show why they're doing it, but we swapped x's and y's. But I didn't do that there. That's also part of swapping x and y. The domain of one is the range of the other. So the domain and range flip. Bless you. So y is greater than or equal to 0, which means y isn't negative for the inverse. It's actually not negative in the other one either, but And you'll see. If we graph x squared plus 4 just with x greater than or equal to 0. F of x restricted to x greater than or equal to 0. And if I do the graph of y, or the F inverse. There's some other things to notice here. The domain is for f of x was 0 to infinity. The range was 4 to infinity. When we switch over to F inverse, these two flip. The domain is now, and you can see it on the graph, 4 to infinity, and the range is 0 to infinity.
Oh, that's because the domain, like just plain before, it has to be equal 4 or greater, because it's not, it's gonna give you an imaginary number. That's not right, right?
Now, that's what happens here in this root, yeah.
Oh, okay.
Up here, it's just a product of the way we graph it. X squared plus 4 moves the x squared graph up 4 steps.
Uh-huh.
But here we can see the
Oh.
domain restriction. The range here is 4 or higher on f of x.
Oh, now I got it. Yeah, yeah.
And that domain, that 4 and higher shows up as a domain restriction in the
You know,
actual inverse function.
I was thinking of it as interval notation. That's why I say that. Yeah.
Good.
Yeah.
And if you do the diagonal, y equals x. So they're reflections from of each other. All right, that's it for 4.1. Let's take a start gander at 4.2. 4.2 is on the exponential function, which I alluded to earlier. So if we have something like y equals a to the x, we want a to be greater than 0. A equals 0 just means y is 0 all the time, and it's boring. We'll take a look at what happens if a is less than 0 in a little bit. We also don't want a to not equal 1. Also boring. 1 to any exponent is just 1. You don't need the exponent anymore. And a is just some number. So a to the x is a unique real number for all x. F of x equals a to the x is a 1-to-1 function. The way they do this is they say. If a to the b power equals a to the c power. Then b must equal c. That's the only way to get them to be the same thing. Now, they got this next part listed really weird. If a is greater than 1. And m is less than n. Then a to the m is less than a to the n. For example, we'll use a equals 2. 2 to the third power, I fucking said 2 and I wrote a. 2 to the third power and 2 to the fourth power. 2 to the third power is less than 2 to the fourth power. M equals 3. N equals 4, and m is less than n.
The first one is m equal 3.
Yes. And a equals 2 in that setup. Then they say if a is between 0 and 1. And again, m is less than n. Then a to the m is actually greater than a to the n. And we'll use those same numbers. Except now I'll use a equals 1/2. 1/2 to the third power is greater than 1/2 to the fourth power. This is 1/8, and this is 1/16. I didn't actually show you the Desmos thing. I fucking loaded on Desmos and I didn't show it. Oh well, I drew it. That works, right? This top one means as x goes up. Y increases. Because m and n are both in the x spot. And y equals a to the x, so like as x goes up 3 to 4, 2 to the third, which is y, goes up, it goes to the fourth. Here it's the other way around. As x increases here, y decreases. So like, let's look at an example. Anyone need this up longer?
Oh, that's fine, that's fine.
What?
I'm fine, I'm fine.
Okay. So, like, let's just make sure we know how everyone's comfortable with what we're doing. If we have f of x equals 4 to the x, let's find f of -2, f of 5, f of 2/3. So this is 4 to the -2. And negative exponents we move to the bottom would become 1 over 4 squared, which is 1/16. I think I bit off more than I can chew with going f to the 5. This is 4 to the 5th power. Let's see, 4 times 4 is 16. Square that is 256. I think it's 1024, I think. Four to the 2/3 here. This is like 4 squared and then 1/3. And we can do some manipulation. This ends up being 2 to the 4th with a 1/3. We end up with 2 times the cube root of 2. Because we would have cube root of 2 times 2 times 2 times 2. One of them can come out. And you're left with a cube root of 2 left over. We did that a while ago. It's been a while. And you can have decimals in there, but like working with decimal exponent, you kind of need to plug it into a calculator. Most calculators have something like this caret function here. So if I do like 2 cubed on my calc, or 2 to the 4th power, I have a 2 cubed button. I would do 2 caret 4 on a calculator. There also you also might have a y x button like that. So you would do 2 y to the x 4 like that. Each calculator labels it somewhat differently. So I talked about f of x as being 2 to the x, and we had actually come up with a table of numbers for them. Well, I gave you the table of numbers. In each thing, these are all exponents. And it's kind of hard to graph it in exponent form. So this is 1 over 2 cubed, which is 1/8. That is 1 over 2 squared, which is 1/4. So if we graph that, Easy to do the ones to the right. To the left, it keeps getting half the distance to the axis. Notice, I am never gonna get a 0 on top of this fraction, no matter what I make x. It makes the y equals 0 or x-axis an asymptote. That is y equals 2 to the x. If we do, that was a equals 2. If we do a equals 1/2, check out what happens. So that was a equals 2. Then we're gonna do a equals 1/2. We've got f of x equals 1/2 to the x. This is 1/2 to the -3, which makes it so you flip the fraction over and make it to the +3, and this makes it an 8. 2 cubed is 8. 1/2 to the -2 becomes 2/1 to the +2, which is 4. (1/2 to the -1 becomes 2/1 to the +1, which is just 2. Zero is 1. 1/2 to the 0 is just 1. Anything to the 0 power is 1. So we had 842 as on our positive side over here. Now it's on our negative side. If I have 1/2 to the first power, that's just 1/2. So all of our fractions are going to appear on the right side now. 1/2 squared is 1/4. And 1/2 cubed is 1/8. And I'm going to plot this on the previous page. There is a connection between these two.
So you just flip them.
We flip them, but there's a reason why. Do you know why we just flip them? Can you tell? Negative is the right answer, but probably not for the reason you think. We had y equals 2x and y equals 1/2 x. But 1/2 is just 2 to the negative 1 x. So this becomes y equals 2 to the negative x. This is y equals 1/2 to the x power, or we can look at it as 2 to the negative x power. And so that like a negative exponent makes it go like big shit's on the left and the small shit's on the right. For all of these exponentials, all these basic exponentials, the domain is all real numbers. And the range does not include 0. It's higher, it's all greater than 0, so 0 to infinity. But don't include the 0. So we saw if you have y equals a to the x is the base one. Y equals a to the negative x just flips it across the y-axis. Like we had up here. Flips across the y-axis. If you have y equals negative a to the x, it flips across the x-axis. No, this is not a is less than 0. We still have the restriction a is greater than 0. This is just doing the negative of the graph. If I were to have negative where a was negative, I would have the negative in parentheses, and we don't want that. So here, our graph is going to do some shit like this. Rather than going like that, it's going to go like that.
You can go a little bit down. I cannot see where you were right now. Thank you.
So this would be y equals negative a to the x. And guess what? Our HK shit is in this too. All the HK stuff we did with the other graphs, shifting a graph by HK. I have y equals a to the x minus h plus k. The graph shifts right h. Up k. It's not the most fun thing to graph. I've been using 2 for an example, we had 4, it could be any number as the A though. The easiest way to do this, I did a lot of numbers for each thing. I recommend just doing 0, 1, and -1. For the base graph. This is 1/3, 1, and 3. So the base graph is this. That's y equals 3 to the x. Do 3x plus 2. I need to switch. H has got to go if this is H is a -2 here because it says positive, and K is negative also. So I got to go back 2 for each point and down 2. And the asymptote moves to y equals k. In this case, y equals -2. So it's probably better to try to put that asymptote in first. It's not that fun to move the graph. It's almost easier to just do the XY chart with -1, 0, 1 straight off this bad boy. But that doesn't give you enough points, is the problem. If you use -1, 0, and 1 here, you have all of the positive numbers. You just have this part right here. You don't see the curve going downward. Graphing it is the least of what we do with these, though. It's just to show you what's going on graphically. What we do with these a lot more often is we use them in equations and we solve them. So exponential equations is actually pretty goddamn important. Unrestricted population growth follows an exponential model. Is an example of this. Like bacteria in a petri dish. Until the petri dish starts actually getting full, then the restriction of the actual shape of the dish shows up. Humans on planet Earth have so far pretty much unrestricted population growth. If we fucking shared food with each other. Like countries starve while we fucking enjoy our fucking Hershey peanut butter cup. You know what I mean? We're over here fucking eating good shit. If we shared the food across the planet, everybody had like equal food, we wouldn't have the same population restrictions that like hunger and shit does. We haven't hit our cap, but there is equations that model like how a cap from environment shows up. But the base one is just an exponential growth. So how do we solve these? Half-life. Radioactive half-life follows exponential decay. It's got a negative exponent. So we'll look at examples of those, I think, in this chapter later on. Let's solve 5 to the x equals 1/125. We're just doing some basic ones now. But I wanted to give you some examples in real life of where this shit shows up. Like, I'm not just giving you some fucking equation and saying solve it. There's a purpose, it's applicable. The way to solve this for now, and it always works, is try to rewrite this as 5 to some number. So 125 is 5 times 25. And 25 is 5 times 5. Which means 125 is 5 cubed, but it's on bottom. We can address that though by making it a negative exponent and moving it to the top. And what does x have to be here? It's gotta be -3. They both have the same base. Both are base 5. So the exponents must match as well. So the exponents, exp, must match as well. Exp is a common shorthand for exponential. In fact, if you have a calculator on your phone that does like scientific calculator, to get to an exponential function, it'll say exp. Sometimes it'll show a to the x, but usually it says or a. I have it. Mine does not have a to the x. Mine only has 2, e to the x and 10 to the x. And we'll go over that why later. We got more to do in this chapter, but it's fucking almost 6 o'clock, so let's call that a wrap. We're almost done with 4.2. Couple more problems that we'll try to work on. Have a nice weekend. There's no school on Friday. It is Veterans Day weekend. Hannah has recruited me to be at the Starbucks at not Prosperity. It's at J Street and Cross in Tulare tomorrow from 10 to 12. If you want to work on homework or whatever, I'll be there. Up to you guys.
I didn't hear you well. You're gonna be in the Starbucks when? What time? I mean
10
when?
to 12 tomorrow.
Tomorrow?
10 o'clock to 12 o'clock tomorrow. It's at
Okay.
J Street and Cross in Tulare.
Oh, okay, yeah. Thank you. Have a
Oh
good day.
yeah, not tomorrow, Friday. Sorry,
Friday?
Friday.
Okay then. Have a good day. Thank you.
Yeah, tomorrow is class day, so what am I talking about? You have a good day too.
Yeah, gonna go get some back, yeah. I'll make it sort it out. Okay.
I